Now, what's the next frontier? So the next frontier, in my view, which is where we are now going forward, I see it occurring in three big areas. So one is the smart water systems. We have gotten to a stage now, with developments on the technology side, where we can actually begin to leverage advancements in sensor systems, advancements in networked technologies, advancements in hardware products and software products, to begin to set up networks that allow us to collect data in real time. We can use that for things maybe like reducing non-revenue water on the drinking water side, or just getting smarter about how we deal with a wastewater treatment process. So if I knew what was coming down the pipe, it might allow me to prepare in a much more serious fashion for what I have to deal with in a wastewater treatment plant. So hurricanes are no surprise, right? Way before the hurricanes come, you have people with models, you have weather stations and you have sensors out in the field that are beginning to give you a sense for what's coming down the pipe. If I could take all that stuff and network it and connect it to my wastewater treatment system and begin to predict how much flow I might have and begin to predict how much higher organic loading I might have, it might allow me to begin to work out what I need to do in different ways, how much I need to maybe overflow, how much bio-augmentation products I might need. So that, I think, is going to be the future, not just on the drinking water side, where a lot of smart systems are focused on right now, but also on the wastewater side. And latching onto that would be real-time optimization. So one of the biggest issues we have in wastewater treatment today is, if I want to get the COD of a sample, I have to wait for 2 hours for someone to take a sample, go to the lab, run a test, and some of the quickest tests will come out in about 2 hours. Now there's some, arguably some technologies that would tell you, we can use UV scanning to do that much more quickly, but then you have to make assumptions that the sample coming in is the same as all the samples you've ever seen before, which may not make sense in an emergency because you might be dealing with a completely different toolkit. But if the COD that I'm reading is 2 hours behind, and if the BOD that I get is actually 5 days late, then how can I optimize anything? So what we're starting to see is that some of these new smart systems, new sensor systems, advanced sensoring technologies are allowing us to get ways of actually reading some of these critical parameters in real time. We have approximations for COD. We're using statistical methods to help us understand what's going on with organic loading coming to the plant. And that allows us in real time to begin to think about, okay, what else? How can I improve operations? How can I, minimize dosage? How can I better do augmentation? And then the next and final aspect of these frontiers is what I call customized biosystems. And I think that's where your technology. So one of the things I was excited about, from all the things I've learned about your technology, is the fact that today, in the wastewater treatment industry, the way we customize our biosystems, the way we alter the populations, the way we select for different populations is by doing two things. One, so yes, we can, so assuming we've done everything we could in terms of orienting the layout in the plant to get whatever bang we can for the buck, the other things we could do is have media-based systems that allow us to select for populations of bugs on the media that would otherwise not be present, or we go ahead and we just augment. If we need more nitrifiers, we pour nitrifiers in. And we've talked about the challenges of doing that. Well, but we know what the issues are, because the issues are that, one, it's hard to really control what's going on, especially with liquid streams that we're feeding into the system. So if I had a delivery platform, a porous media in particular, that would allow me to latch on some microbes to it, some really interesting things could potentially begin to happen. And I really think that that's what your approach does. And I'll explain why I think that. So bacteria are actually pretty small. This is a 2-micron scale system. The average diameter of a typical bacteria might be about 0.45, 0.5 microns. It's quite small. But it also turns out that our porous structures are also pretty small. So if I look at a porous media, and this is an electron micrograph from a porous media, these holes are excellent sites that can allow you to selectively do a lot of interesting things. When I was in the industrial gas business, these pores allowed us to actually separate nitrogen from oxygen, because the sizes of those molecules were different, and we could get some to actually get trapped between these pores, and that was enough to actually give us about a 90-95% in some cases separation of those gases. So these pores can be excellent sites for buds. Everywhere there's a hole is a potential place for me to put a biomass. Everywhere there's a pore, and even on the surface, is a potential place for me to put buds. And then some really interesting things also begin to happen. Is now it can be a delivery platform, right? It's a surface on which I can load my buds onto. And if my buds are loaded onto it, and I can hopefully find ways of putting them into those pores, there's some interesting things that will happen. I can deliver stuff, I can make that a habitat for my buds. They can actually put themselves into those holes, they can attach. Anytime buds have a surface, that's one of the reasons why we have to deal with cavities all the time. They're going to express a polymeric material that will allow them to attach, right? So once they're there, they tend to stay. And then I can also create micro-oxic environments. So the outside can be oxic. It can have a DO of about 2 on the outside. But inside of those pores, I can actually have anoxic and anaerobic environments. I can create different types of environments within the structure itself. I can begin to do things like have selective, so I can have aerobic buds on one side, I can have anaerobic buds going on one side, I can potentially have the type of environments that allow me to do within my pore structure, the things that I would need 3 different tanks to do in a typical wastewater plant. It might allow me to grow PAOs in a plant that's completely aerobic. So there's a lot of potential, I think, in terms of innovating around how we think about these structures. It can change flock density effects. The density of your porous material tends to be slightly higher, sometimes significantly higher than the flock itself. It could potentially help with settling and those types of related issues. It certainly would extend my sludge age, which means I can have a system that has a sludge age of 3 days, but because of this environment that I've created, I can actually have extended sludge ages, and if you do exactly what some of those biofilm systems are doing. It can also provide me with selective sorption. So remember, with porous media, I can actually separate nitrogen from oxygen. With porous media, I could selectively pool different types of CODs. I can pool more soluble COD that would typically not be exposed to the bud. So it also becomes a medium that can allow me to do different types of sorption. And then obviously the goal there is to also be selective in terms of the microbe that we can lay onto that structure. And so the more I've learned of your technology, the more convinced I am that you guys certainly have the elements of what I think this aspect of innovation in Water 3.0 is going to be, which is how do we, now that we've mastered some of those other areas, how do we actually begin to go back to the basics of enhancing and innovating around the buds themselves. So again, the more I've learned about your technology, the more excited I am about the fact that you guys certainly have something remarkable here, and I think WEF certainly agrees that you guys have an innovative product on your hands. So I want to congratulate you, follow on in Mary's footsteps, to say It's remarkable, and this is certainly one of those technologies we're going to be looking for to do big things and to make some interesting things happen in our industry. So thank you for sharing this, allowing me to share some of my thoughts with you over this period of time. Thank you.